There is nothing more terrifying than a shipboard fire. At sea, there is no place to run and no fire department to come to the rescue. The potential for catastrophe creates the need for constant vigilance among the crew to prevent the loss of life, the damage to the ship, and the damage to the environment that can result from fire. Every seaman must pay constant attention to fire prevention and be capable of serving as an effective member of a fire response team. This program offers an overview of basic firefighting in accordance with Table 6 of the STCW Code as amended in 1995. It offers self-testing and assessment features that enable you to measure your knowledge and document your participation in your vessel's training, drilling, and assessment program. As you watch the videotape, keep in mind that your vessel may have additional policies and procedures that you must follow. Ships use a system of alarms to warn personnel that a fire emergency exists. The general alarm for fire and emergency sounds like this. Other alarms are triggered by installed fire detection and extinguishing systems. Each vessel has a variety of internal communication capabilities, including messengers, telephones, intercoms, radios, and public address systems that can be used to coordinate fire response efforts. To communicate with other vessels, the Coast Guard, or a shoreside fire department, the bridge uses a variety of external communication systems, including marine radios and telephones, as well as the ship's whistle and signal flags. Firefighting efforts are organized by the ship's fire control plan. Station bills and station cards establish the chain of command and assign emergency duties to each crew member. The master serves as officer in charge with overall command of the vessel. The on-scene leader serves as officer in charge at the fire scene.
Okay, let's get a couple guys backing up on this hose. Mike!
A hose team leader commands each hose team. The nozzle man directs the stream and chooses the stream pattern. The backup man helps to control nozzle reaction pressure and move the hose. Additional crew members perform duties as assigned. It is each individual's responsibility to follow the chain of command and observe fire safety procedures. All fire squad members must be equipped properly. Fire zones should remain clear. All personnel should be familiar with escape routes from living and workspaces. The fire control plan identifies primary and secondary escape routes from all regularly manned spaces aboard the vessel. Your duties are listed on your vessel's station bill and the station card in your stateroom. Study these documents and learn your responsibilities as soon as you come aboard. Ask your supervisors to explain anything you don't understand. Each vessel is required to stage periodic fire drills. These exercises are scheduled by the master and conducted by the mate or team leader. To be effective, fire drills should involve different locations, different scenarios, and different classes of fires. During familiarization training and drills, you'll learn the location of the firefighting appliances aboard your vessel and be given the chance to practice using escape routes from living and workspaces. Practice escaping with your eyes covered. In a real fire, you may be blinded and disoriented by smoke and debris. In a crisis, your ability to survive may be directly related to your familiarity with the vessel's escape routes and your understanding of fire travel and heat transfer. Everyone aboard your vessel, including passengers, must be instructed in methods of quickly reaching safety. A fire requires fuel to vaporize and burn, heat to raise the temperature of the vapor to its ignition point, and oxygen to combine with the fuel vapor. The mixture of heat, fuel, and oxygen is referred to as the fire triangle. A fourth component of fire, referred to as the chain reaction, combines with heat, fuel, and oxygen to form the fire tetrahedron. Remove any leg of the fire triangle or interrupt the chain reaction, and the fire will be extinguished. All matter exists in one of three physical states. Matter in each state can serve as the fuel for fire. Solid materials like wood, paper, and cloth are common sources of fuel. Vessels carry a wide variety of solid fuels, ranging from furnishings to cargo. Combustible metals, including magnesium, titanium, aluminum, and sodium, are dangerous solid fuels that may be carried as cargo. The burning rate of solids varies according to their configuration. Bulky fuels burn longer. Finely divided solids like dust or shavings burn faster because they present more surface area. Combustible and flammable liquids are another form of fuel. These materials are most commonly found aboard ship as bunker fuel, lubricating oil, diesel oil, and hydraulic fluid. Bulk liquid cargoes may also be classified as combustible or flammable liquids. Liquid fuels release vapors more readily than solids because they have less densely packed molecules. Pound for pound, liquids produce about 2.5 times more heat and liberate heat 3 to 10 times faster than wood. Combustible fuels have a flash point above 80 degrees Fahrenheit. Flammable fuels have a flash point of 80 degrees Fahrenheit or less. The flash point is the temperature at which the fuel is capable of being ignited. For example, the flash point of gasoline occurs at minus 45 degrees Fahrenheit, while lubricating oil has a flash point of 400 degrees Fahrenheit. Vapors produced by petroleum-based fuels are heavier than air and seek low places, dissipating slowly and traveling to distant ignition sources. Gases represent a dangerous form of fuel. Gases are always in a vapor state, ready to mix with oxygen and heat to cause ignition. Heat initiates the chemical reaction called combustion. It can be caused by the flame of a match, by sparks, by friction, or by electrical short circuits or electrical arcs. Heat sufficient to ignite a fire can also be produced by chemical reactions. Air normally contains 21% oxygen, 78% nitrogen, and 1% other gases. A minimum oxygen concentration of 16% is needed to support visible flaming combustion, although smoldering combustion can take place in lesser concentrations. The chain reaction starts when the burning vapor produces heat, which generates more vapor. This produces still more heat, vapor, and combustion until the process reaches its maximum rate and levels off, producing a steady burn. This chain reaction continues until most of the fuel is consumed. Fire safety is every seaman's constant responsibility, on watch or off. You must be capable of recognizing fire hazards and of practicing effective fire prevention. Smoking is an obvious hazard. If you smoke, make sure you do so only in designated areas and dispose of your butts and matches properly. Electricity is a common fire hazard. Never overload electric circuits or outlets. Inspect wire runs, cords, and electric tools regularly. Replace defective electrical components. Be alert to the danger posed by defective lighting. Static electricity also represents a fire hazard. On the deck of an oil tanker, for example, all electrical equipment must be intrinsically safe, and even common devices like cellular phones are prohibited. Engine rooms are filled with fire hazards. Repair or replace lagging and insulation as needed. Fix oil and fuel leaks and clean up spills. Maintain a clean engine room.
There's nothing more important than housekeeping. If you keep the engine room clean, well lighted, well painted, preventing any accumulation of oily rags, just everything you've heard of and you think of as common sense, that's your primary firefighting.
Galley operations can create fire hazards. Practice good housekeeping. Mop up spills immediately. Clean range hoods and fan flues frequently. Dispose of paper garbage in designated receptacles. Don't spill cooking oils on stovetops or overheat cooking oils. Maintain electrical installations in safe condition. Be sure you know the location of electric disconnect switches. Practice fire prevention in your berthing area. Don't smoke in bed. Don't use unauthorized electric fittings or appliances. Don't empty ashtrays into trash cans without ensuring that all cigarette butts are out. Cargo areas can also present fire hazards. Practice good housekeeping. Ensure that cargo is properly stowed and secured. Observe no smoking warnings. Welding and cutting operations require hot work permits and the maintenance of a fire watch. Sloppy work habits increase the fire hazards associated with dangerous tasks like this. Fuel oil transfer and service operations must be conducted in accordance with federal rules designed to eliminate fire, toxic, and pollution hazards. Crew members aboard tankers, chemical carriers, and gas carriers must have specialized cargo handling and fire training. Spontaneous ignition occurs when heat and vapors build up in spaces that lack adequate ventilation. Poor housekeeping and careless work habits increase the fire hazards associated with shipboard operations. Conduction is the transfer of heat through a solid. It occurs when matter conveys heat without visible movement of the matter itself. Conduction is controlled by removing the fuel and cooling the burning material. Convection is the transfer of heat through the motion of heated liquids, gases, smoke, hot air, or flying embers. Heat traveling by convection moves both vertically and horizontally. It is controlled by setting fire boundaries. Radiation is heat transfer by electromagnetic or radiant energy propagation. It is the transfer of heat from a source across an intervening space when no material substance is involved. It occurs in a straight line of travel and is controlled by applying water fog as a shield. Class alpha fires involve common combustible materials that produce an ash. Class alpha materials include wood, paper, cloth, rubber, and most plastics. The most effective extinguishing agents for Class alpha fires are water, foam, and dry chemical. A Class Bravo fire involves flammable or combustible liquids, gases, greases, and similar products. Class Bravo fires can be controlled by cutting off the supply of oxygen and vapors or by shutting off the fuel supply. Liquid Class Bravo fires are best extinguished with foam, halon, or carbon dioxide. Securing the fuel supply is the best means of extinguishing a gas fire. Class Charlie fires involve energized electrical and electronic equipment, conductors, or appliances. In extinguishing Class Charlie fires, the first priority is to protect firefighters from the electric shock hazard. Current to the affected area should be shut off at the source. Non-conducting agents such as carbon dioxide or halon are the best choices for these fires. Although dry chemical is effective on Class Charlie fire, it is also highly corrosive and damaging to equipment. Water must be used with extreme caution. Water can only be applied to a Class Charlie fire as wide fog with a minimum 4-foot standoff distance. A water stream should never be used. Class Delta fires involve combustible metals such as magnesium, sodium, phosphorus, titanium, and aluminum. The best method of extinguishing a Class Delta fire would be to jettison the fuel. Where jettison is impossible, special extinguishing agents called dry powders are used.